talk about a different type of special quadrilateral that's a trapezoid. So yesterday we talked about special parallelograms, rectangles and rhombuses and squares. Today we're going to talk about a different kind of quadrilateral that's special, and that's a trapezoid. Somebody remind me what the definition was for a parallelogram. What was the defining characteristic of a parallelogram? Not necessarily. Unless you're contributing an answer to me, we don't need to be talking. Okay, so the defining characteristic, a few people have said it, opposite sides are parallel. Both sets of opposite sides are parallel in a parallelogram. In a trapezoid, we have exactly one set of parallel sides. So a parallelogram has both sets of opposite sides parallel. A trapezoid has exactly one set of parallel sides. So kind of a traditional picture for a trapezoid is something like this, where we have one set of parallel sides and the other set are not parallel. We call the parallel sides the bases and the non-parallel sides the legs. Don't think of bases as meaning top and bottom, because we can also draw a trapezoid on its side, and the bases are still the parallel sides, not the top and the bottom. Okay? So always think of bases as meaning the parallel sides. The legs are the non-parallel sides. An isosceles trapezoid is like an isosceles triangle in that it has at least two sides congruent. Remember, that was our definition of isosceles triangle, was at least two sides congruent, but we actually still called it isosceles even if all three were congruent. In an isosceles trapezoid, at least the legs will be congruent. They may be congruent to one of the bases as well, but at least the legs will be congruent. In an isosceles triangle, we had a theorem that told us if it's isosceles, if the two sides are equal, then the opposite angles are going to be equal, or the base angles will be equal. We have a theorem like that for an isosceles trapezoid as well. In an isosceles trapezoid, the base angles will be equal, but we actually get two sets of base angles. In an isosceles trapezoid, we get along one of the parallels and along the other parallel. So we get two pairs of congruent angles here. But they're not all congruent to each other. What can you tell me about the lower left angle and the upper left angle? They're not congruent to each other, but they do have a relationship. They're supplementary because we have parallel lines, and those would be same side interior angles. So each set of base angles is congruent, and one base angle is supplementary to the other base angle. Okay? The median is defined as being the segment that joined the midpoints of the legs. So if I have a trapezoid and I take the midpoints of the legs and connect them, that's our median. Two facts are true about the median according to Theorem 519. It is going to be parallel to the bases. So it splits that trapezoid into two trapezoids. It's going to be parallel to the bases. And also its length is going to be the average of the bases. So if the top is 4 and the bottom is 8, what would the length of the median be? 6. How do we find an average? Add them and divide by how many there are, and there will always be 2 in our case. So add them and divide by 2. Okay, and that will give us the average, which will be the length of the median there. So our rule was that the median length is the average of the bases. How do we find an average? Add and divide by 2. So for the first one, I would do 8 plus 16 and divide that by 2. 8 plus 16 is 24, divided by 2 is 12. So that median should have a length of 12. For the middle one, remember that your bases are the parallel sides, not necessarily the top and the bottom. So for the second one, I want to do 5 plus 10, the parallel sides, divided by 2. 15 divided by 2 is 7.5. 7.5, 7.5. Or you could leave it at 15 over 2, which I think is a totally great answer. Okay, so don't feel like you have to turn it into a decimal or a mixed number. Number 3 looks confusing because we have those variables in there, but follow the same rule. Add them together, divide by 2. So 11 minus x plus 11 plus x divided by 2. What happens on the top of that fraction? The x's cancel. So 11 plus 11 is 22. Minus x plus x goes away. 22 over 2 is just 11. I have one more question for us. If I have a trapezoid, and that's our median, and I know that, let's say the top is 10, and the missing base.
You would add the difference. Like, you would multiply 16 by 2 and subtract 10.
Okay, so we could set up an equation, and we could say that 10 plus x, like we were doing on the other questions, add the bases and divide by 2, should equal the median, but in this case we already know what the median is. So we can say that it equals 16. Multiply both sides by 2 to get rid of the fraction. 10 plus x is 32, so x is 22. Subtract the 10 from both sides. Okay? Questions?
Why does it look like it's just like 10 plus 6 is 16, and 16 plus 22, or 16 plus 6 is 22?
I'm sorry, what?
It's going to be like that where you add the same amount?
I want to say yes, but I'm not 100% confident on that. I have to look at a few more examples and play with a couple more numbers. But I want to say yes. Add 2.5, add 2.5, add 4, add 4. So I'm thinking that's a good rule. Yeah. I don't think it can be coincidence that many times. Other questions? Okay, your homework is going to be what is printed, but before you get to doing that, I would like you to please